Okay, it's me again. This is section 7.6, modeling the number of successes in a fixed number of trials. So, number of successes, a fixed number of trials. There is a Khan Academy video. Whee! And some of the notation is used in there, so we'll kind of see all sorts of notation. Generally speaking, you want to make sure you're showing some sort of work, given that this is such a calculator-heavy section, and so I'll make sure to note that as it happens. Section 348, there's an example with Pascal's triangle, so I'm going to do that on the next slide. And then it's got that like game machine thing, the like Plinko, whatever it is. Please read over 350, 351. Right, make sure your notes are good, anything that makes sense or needs to make sense. And then again, Khan Academy. One thing I am going to do is go to the next page. Okay. I used to teach Algebra 1 too, and we would always look at Pascal's triangle. If you had Miss Maiden last year, I know that you also looked at this. So the idea is that, well, there's the pattern, right? And we can find the binomial coefficients from Pascal's triangle. So one thing that's true is that the ones are always on the outside, and that there's a bit of symmetry, if you could say such a thing. And you add the like top two to like get the next bottom row. Okay, so this would be a 6, but like I have a 6 here too. Yeah. This would be 35. This would be 28. As with this, yeah, and so on. So one thing is that like this equals 1, this equals 2, this equals 4, this equals 8. So there's like lots of cool patterns that happen with this. One thing that does happen is that the rows of the triangles are represented by the binomial coefficients, which is cool. So I would like add this into your notes if you haven't already. Binomial coefficients in row n plus 1 of the triangle are represented by the following notation. And then we are going to see this, and it's always with a C, which is for coefficient. And we're going to talk about n and r here in a second. The factorial is in your calculator, so I want to add that right here. So your factorial, that's your, right, your exclamation mark. It's your math button. You go over to prob, and I think it's number 4. Like the option is number 4, just like for the record. Okay, so this is from an example, right? So like you see the notation. So n would equal 5, r would equal 2, right? So like that's how they set it up. It equals a value. So here we get 10. And it talks a little bit about factorial, just like for the record, factorial. So if you look at your book, it has, this is page 350, it has like, you could do like a heads or tails, like a coin flipping thing. It has like a nice little investigation if you want to try that. We don't have to because there's not time, and also I'm not there. But the idea is that like you're using these coefficients from the Pascal's triangle to build a binomial distribution. So what I'm going to do over here is, what did I write? Why do we care? I'm going to zoom up. So I'm going to change colors. So like, why do we care? And maybe you're like, well, I don't. Well, okay, that's fine. So if we have coefficients, we can have a distribution. So I'm going to say now we can have a binomial distribution. Yay! And this is good for things that have like, well, a binomial, like a yes or no, or success or fail, or like it works or doesn't work. It's true or false, right? Like a binary sort of thing. So the definition, I'm gonna make sure, and I'm like taking this from the book. In a sequence, this is my definition of n, I'm gonna put a box around that, independent trials, oops, that's not at all how you spell that. Oh wait, yes it is. Trials of an experiment in which there are exactly 2 outcomes. And I wish I almost would have put a box around independent. So we have, again, success and failure, just like reality over here, with constant probabilities, meaning that they don't change. So if you say it's likely, it's like 1 out of 2, then that has to be true, like the whole way through. I'm going to write it like this. P of success equals P. P of failure equals what? Dun, 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 dun. 1 minus P. Okay, and then I'm going to put like a comma. So if this is big X, denotes the discrete, remember we talked about that last week, or whatever week that was, random variable equal to the number of successes in n trials, right? So there's that n trials, independent trials. Then the probability, I'm going to scoot this up. It's shorter looking in your book, eh? The probability distribution function, oh gosh, remember there's a function, of x, big X, is dot dot P of big X equals little x. Here's our binomial coefficient. And this, it uses r on the other, because that was like for rows, right? But generally it's an x. So P of x. And then this is your 1 minus P. Sometimes this is called Q. Just want to say that out loud. X is an element. Remember we talked about that. Little x is an element of these numbers. What number set is this again? Ooh, it's your whole numbers. Okay, so in words, in case you didn't have enough words, big X is distributed binomially. Okay, well you try saying it. With parameters N and P, those are important. And then in symbols, this is it, y'all. Big X, tilde, big B, and P. Yeah? Okay, let me do some highlighting because you know that's what I like to do. Binomially. And then your trials, are your n, and then your p, what happened to your p? Your probabilities, p, 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 and then x is your function thing. Yeah? Okay, cool. Love it. Again, this is like super useful for research. It's like how Google tells us something's spam, right? Spam or not spam. And it sort of builds off of these coefficients, right? The fact that I can have this, right? So I see that C over here. Okay. Hold on, let me not do that. Okay, next. Okay, do you have these in your notes? If not, add them. This is what I just wrote. So here it is. If that is, I don't know what you're doing. Okay, so all that to say, now we can solve these sorts of problems. Example 22 is on page something. Page 352. Let me add it up here. But let's try it before you look ahead. Multiple choice quiz has 6 questions, each of which has 4 likely options, A, B, C, D, right? We get that. If answers are guessed, and if X represents the number of correct answers, right? So that would be a success. Find P of X equals 2, X less than or equal to 2, X strictly less than 2, and then here's a good one. X is greater than or equal to 3, but less than, strictly less than 6. I know, I'm here with you. Okay, one thing that you need to do first, so I'm going to write this over here. N is our trials. N'est-ce So N equals 6. Yeah, right? Because there's 6 questions. These are the questions. Okay, just saying. I'm just saying. Our P, probability, P equals prob. I have 4 likely options, but only 1 is correct, right? So that's a 1 out of 4 chance. Yeah? Because only one is correct. Okay. Capiche? 4? Yeah? Okay. So here's how we write this. Here's the notation. So this would be like showing your work for IB. Big X, it's a binomial distribution, so I have my B. 6, comma, I'm going to use 1/4, but you can use 0.25 if you want to. Yeah? Okay, so you need to use calc for this. Like, you have to. So I have my calculator here. Obviously you can't see it because time, space, continuum. So what you're going to do is do second vars, because that's our distribution button. You'll see some stuff there. You'll see normal, inverse normal, scroll all the way down to A. So for this first one, we want A. And that's our binom PDF. And it has a little like huggy boy. We also are going to use B, binom CDF. It depends. We'll talk about that. Okay, so this is your calc. Okay, so for part A, it says find the probability of X equals 2. So 2 correct answers. So what I'm going to do A down here. So P of X, big X equals 2, right? So this is like showing my work, yeah? Equals, I'm going to use my calculator. So I wish you could see this. It asks for my X value. My X value is what? 2. So I get this value 0.2966, 0.297. Okay, so what you can do to like show work, and I'm gonna write it over here in purple, is like this is what my calculator said. Binomial PDF 6. This one does 0.25, so I'm gonna do that. And then 2. So again, just like for the record, this is my n value. This is my probability. This is my x value. And then when you're in here in your calculator, this is your trials. This is your, it just says P. And then this is your x value. Yeah? And then like paste because you enter it. Okay, so that's part A. Part B is almost the same thing. So I'm going to write B. This is A, just for the record. So it wants me to say x is less than or equal than 2. So what I'm going to do is I'm going to use my, oops, I did it. Okay, so I'm going to use my binomial continuous. So I still have 6 trials. I have the same probability. My x value, though, is now 2. But I'm going to say up to including 2, or less than. You know what I mean? Less than. You know how that is with the words. Oh, gosh. 305. It's hard to do this without a live audience. It's like online learning flashbacks. Okay, so these are different, yeah? Like these are different. This one is x equals 2. This is less than or equal to 2. So this is continuous. This is discrete. So for this, I need, my calculator is going to read binomial CDF. Same thing, 6, 0.25, because it's 1/4, 2. Yeah, so it should literally look different in your calculator. One is going to say CDF, one's going to say PDF. Okay, here is the thing. We're doing part C. That's not what I wanted to say. So part C is different. How is part C different? So it's a strict inequality. So less than 2. So what this means is that I would have P of x equals 0 plus P of x equals 1. Right? Because that's less than 2. For this one, I would have had all 3 of them, just for the record. Oh my gosh, I can't do this. Plus P of x equals 1 plus P of x equals 2, right? I would have had all 3. But here I only have 2. So one thing we can do is we can use our continuous and just say up to 1, right? So I can use, this is like, well, actually, let me rewrite it first. 1. Hear me out. Hear me out. So this is going to be, I'm just going to tell you what it is, and I'll show you the calculator. 5, 3, 4, this spot. So like that's that. And it is binomial CDF, right? Because I'm including 0 and 1. So that's my continuous. Oops, sorry, it jumped to the next page. 6, oops, comma, 0.25, comma, 1. Yeah, so like, be careful. Yeah, you could do it piece by piece and add up. That's totally fine. So this you would like add up binomial PDF, or you could do the cumulative continuous. Yeah. Okay, the last one is a little bit trickier, and I did calculations. I feel like there's a way to do it how it's written, but I can't remember, and I am not in a mental state of remembering right now, so we're just doing the best we can. Probability. So x is squeezed. Sorry, that's a big X, y'all, but it's not a chi-square. Okay, so this is the same as saying, right, so this is a strict inequality, so this is the same as saying 3 greater than or equal to big X less than or equal to 5, right? Because this is not equal to 6. So what I did, and again, you can, whatever works for you, I found P of X less than or equal to 5. And that was almost the whole thing, which in theory makes sense because there's 6 questions, right? And then I found second probability of X less than or equal to 2, because, right, so like I'm gonna like squeeze it out, I'm gonna like subtract it. So then I subtracted. So in my final iteration, so that's my original problem, this is what I found. Whee! Yeah. Okay. So one thing that happened a lot last year is like students would be confused on when to use, so like when to use Binomial PDF versus Binomial CDF. Yeah, so it's all about the equal sign. And again, you could like do it in steps, but it's sort of figuring out like what is it really saying, and then showing work is one of 2 ways. Like either you're gonna like write out these statements. This is like showing your method, I guess. And you could also like write it out like that. Yeah. Okay. Kind of weird. I know. Next. Oops. Oh, this is, I like accidentally wrote on it, my bad. So this is sort of what I just said. It's essential to examine the context of a problem in order to, well, not really, but what I said earlier, whether the binomial distribution is appropriate model or not. So again, like what is it counting? Trials should be independent. So that means like if you take a marble out of the bag, you put it back. So it can't like change anything. Right? The probabilities have to be constant, which is like kind of a weird thing. How many trials are there? That's your n, yeah? And then the probability, I'll change to green. It should always be the same. So again, if I take a marble out and don't replace it, I'm going to change the probability. So that is my P for probability, yeah? So this is like kind of important because in the future, I'll say important, because we're going to have normal distributions. I know. So many smiley faces today. Wow. Next. Oh, Christmas. Okay. Alerts. Oh, I already just said that. But in my notes I said alert. Okay, example 23. This is on page 7 million into example 23. This is page, it's about a coin, right? 352. They do an okay job of explaining it. My least favorite thing about this book, well, you know, there's so many, is that it's like in the example for the notes, it says use technology to find the binomial probability. And you're like, okay, cool. What if I forgot how to do that, right? It like doesn't tell you more than that. So everything is fine, nothing is horrible. Okay. Example 23, it says for each situation, state if it's distributed binomially. If so, find the probability. Okay, got it. A coin is biased, so the probability of a heads is 0.74. The coin, so that's my probability. The coin is tossed 7 times. A is the number of tails. Find P. A equals 5. Okay, so it's a coin toss. So there's 2 outcomes. It's a fixed number of trials, and the probability, even if it's biased, it's still going to be that probability. So A is okay. So A is yes, binomial. Binomial, I was like distribution. So I'm going to say that over here. So I'm going to say coin toss, which means there's 2 outcomes. It's a fixed, that's a coin toss. Fixed number of trials, and that was 7, right? And then the probability equals 0.74. So yeah, we're good. We're chilling here. Yes. It says tails. So this is the thing that always gets me, is that it says the probability of a head is tails. So equals 0. So tail is the rest, right? 2, 6. So what we are going to have, and we're using A. So we have A, this is my binomial. I'm going to have my trials, which is 7, I said, and my probability is here. So again, this is like showing my method. This is also, if asked for tails, but it gives you heads, right? So make sure you pay attention. This one is equals 2. So again, if I was there, I'd say, which one are we going to use? And he would say, discrete. And I would say, yes, good job. I ran the calculations. 137. Parenthesis, I'm going to put a box around that. And then my calculator said this. Zoom enhance. It said, I'm going to write it over here. It said binom PDF. And it was 7. And then it was 5. I'm just going to put a little box. Yeah? So that's what my calc said. Please notice that your calc, you have to input, so like need to input X value. In your setup, you don't, right? Because like X is the variable that changes, the random variable. Okay. When I did this, I did it out of order, cum dab. So let me find where I did B. This is going to be enough space. No. Okay, I'm going to read it and then I'm going to move it. A bag contains 12 white chocolates and 7 dark chocolates. Oh dear. Chocolate is selected at random. Type noted and then eaten. Yes, let's go. Repeated 5 times. B is the number of dark chocolates. Find P of B equals 4. But if you eat it and put it back, then, wait, no. If you eat it, you don't put it back, so you change the probability. So this is not going to work. It's not independent. So let's say that up here. Sorry. So B, I'm going to say chocolates. Oops, that's not how you spell chocolates. Chocolates are eaten. Therefore, it's not independent. Right, like P would change. That's P. So what do we say? I'm going to say cannot use by, oh my gosh, you guys. By no, I cannot. Should be NOLA. Binomial distribution. Sad face. That's okay. So maybe I'll say like a nope, and then why don't we do a green? Yep. Okay. C states what? C, a bag of dice. So 10 red dice, 1 blue dice, 7 yellow dice. Dice is selected at random, so this should always be random. The color of the U, because we're international today. Noted and replaced. Yes. Smiley face. Repeated 12 times. That's our trials. N. C is the number of yellow dice recorded. Find P if C less than or equal to 6. Okay. I think this works. Why does this work? Should we go over here? Let's go over here. Okay, I'm gonna go over here. Oops. Uro. What did I say in my notes? Good question. Oh, I found the probabilities. Well, I would. So I said 10 out of 18 was red. That's a 10, leave me alone. 1 out of 18 equals blue. Oops. And then 7 out of 18 is yellow. Okay, good to know. And then what did I say? I said because the dice are replaced, this is okay. And I have, right, my trials, my N. So what did I say? I said C, because I was thinking of the color. Oh no, it tells me C. Never mind, that was not mine doing. It's my binomial distribution. I have 12 trials, and my probability for yellow is 7 out of 18. So I care about yellow. So again, this is my like notation. And then it says find P, C less than or equal to 6. So then this tells me my X. I'm gonna put it over here. When I did this, I found 0.86067. I hope that's correct. Right? So, boop, boop, boop. Yeah? And again, in my calculator, it said this. Binom CDF. CDF. Because it's up to and including 6. I hope I'm saying that right. You know what I mean? C is less than or equal to 6. Okay, I lost my train of thought. 7/18. If you do a decimal, that's fine. I don't know what that is, and I'm not about to find out right now. Thank you. Yeah? Okay. Cool beans, as the youth say. Part C, Kieran plays lottery. Oh dear. In which the probability of buying a winning ticket. Let's see a pink. Probability winning ticket. So either it wins or doesn't is 001. E is the number of tickets. Kieran buys. And what's it? Ooh, okay. Do you see the issue? Until. So this is not gonna work. We can't do it. And you should be thrilled. So not binomial distribution. It's not a fixed number of trials. So even if the probability is in theory the same, it's not going to work. Or wait, no, it's not independent. So it cannot use. Okay, so I'm going to say and not independent. Sad face. Okay, so D was no, C was yes. Okay, so va? It's messy, but it works. Okay, next. Oh, this problem. Okay. It's fine until part B. So part B, it took me a second, and then I figured it out, but it took me a moment. Okay, solve this problem. Ready, set, go. What am I doing? Get out of here. So 6 children. Find the probability that there are exactly 3 girls. And then the probability that there's 3 consecutive girls. So here, let me actually make that. That's different. Yeah, that's a different life we're living. Part B is like its own thing. So I said you'll need a log. And that is true. Also, it's like unrelated to the first problem. Listen, we're doing the best we can. Okay, so let's do part A. Part A, in a family of 6, find the probability there's 3 girls. So, my girls are distributed binomially. So I have 6 trials, and I'm looking for a girl. And again, it's gender binary. So that's going to be 1/2, right? 50%. So I'm going to say it over here. There's 6 kids. And I'm going to say 50% chance it's a girl. Gender binary. So it's saying find P of G equals 3. So just 3 girls. Doesn't matter what order. So this is my discrete, right? So when I ran this calculation, that's a 5, everyone. 0, 3, 1, 3, if I round. Okay, so again, in my calculator, binom PDF, 6, 0.5, 3, right? Because that's x equals 3. And again, maybe you're new here. Maybe you just hopped on the old Zoom call. 6 kids, right? So there's my 6, there's my 6. 50% chance it's a girl. 50% chance, 50% chance. Hear me out. Well, or don't. Hear me out. It's equals 3. That's why it's PDF. Just saying. Okay, so well, it's good. All right, so that was nice enough. Consecutive girls. So that means the girls have to be in a row. I only have one sister, so this, it's a different concept for me. So what can happen is you can have a girl, 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 boy, boy, boy. You can have a boy, right? You're just going to like shift these over. And then you can have a boy, boy, girl, 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 boy. You can have a boy, 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 girl, girl, girl. And I think that is everything. So there are 4 outcomes, right? Because I have like 4 rows. 4 outcomes have the probability of 1/2 to the 6. There's 6 kids and it's a half chance, right? So I'm going to say P of 3 consecutive girls equals 4 1/2 to the 6th power. I know. I multiplied this out and I said 4/64ths, or it simplifies to 1 out of 16. I know. So that's that, by the way. One thing that the book says that I didn't think about because I was like over this problem because it was annoying to me, to be very honest with you, is that oh wait, no, I didn't finish this, sorry. I forgot that I didn't really have to do this, but leave it alone. Okay. So this is like our Yahtzee, by the way, in case you were having flashbacks. That's very fair. So one thing is that like it's more likely, like 31% versus like 6%. So it's more likely to have 3 girls in any order, right? then 3 consecutive. Oh my gosh. So that was like one thing that our book did that I didn't think about doing that because I was, again, just like over it. P of 3 consecutive girls. Right? So like, smiley face. Okay, pause. Okay, I just need a moment for myself. So that is part A. Part B is unrelated. So again, I'm not really sure why it does this. I wish I knew. So a study shows that 0.9% of the population of over 4 million carries the virus. Okay, great. Small sample of the population. So the probability of the sample having no carriers is less than 4%. I know. So I'm going to go to a new page. I know. Let's make this better though before I go. Okay, so this one is part B from the previous. And basically what we have is part B. Okay, so we've got this. N. Okay, so that's my probability, right? Like my probability is 0.009. I will say, so it gives you like a hint in the book. Again, that's not great. It says find, or wait, no, this is like the problem. Smallest value of n, so that's such that P of C equals 0 is less than 0.4, 40%. And it tells you the answer, right? And you're like, great, cool. How did you get that number? Great question. If you check it, it works. So one thing that we have to do is we have to use our binomial coefficient for this. And it took me, again, a second to figure out what was going on. So if it comes to you faster, please share your wisdom with the class because gosh gracious. Here's my probability. So I'm going to use my coefficient equation from earlier. I'm going to do this. I guess maybe I should write it out for you. That would be helpful, hey? I'm going to write it over here. I'm a hot mess, right? So your probability equals, right, because my probability is 0.4. N factorial, n minus x factorial times x factorial. Oh, Lord. Oh, dear. P to the x, q, or the 1 minus p, and minus x. So q is 1 minus p, just like for the record. Okay, so from here, maybe actually I'm going to erase this for a second. I want to find, find n, right? WTF, n. So I want to find this n, and this n, and this n. Yeah? I know x. Wait, do I know x? Yeah, x is 0. And my probability is up here, right? So I have some knowns. Okay, calm down, everyone. So I'm going to start over. So 0.4, right, because that's this over here, is equal to n factorial. I don't know n. N minus 0 factorial times 0 factorial, which is just 0, by the way, times my probability, which is 0.009, raised to the x. So x equals 0, just in case that wasn't clear. Sorry. Times q is my 1 minus my probability. So I'm going to say in parentheses 991 n minus 0. So q equals 1 minus 0.000. Oops, 0.009. Okay, I know. Let's do this line Okay, so n minus 0 is just, also this is just this, divided by, wait, did I do this wrong? Is 0 factorial? I'm having a moment. This is just 1. And then this is just 991 to the n. Y'all, I just had a moment. So 0 factorial is 1. I don't know. Leave me alone. I don't know. I can't do that right now. Smiley face. Oh, thank God. Okay. So this is just, right? Like this is 1 then, right? So this is 1, whatever n is, doesn't matter. This is just a big 1. So you get 0.4 equals 1 times 1 times 0.991 to the n. So that's just 0.991 to the n. Okay, how do we undo an exponent? I know, what a great question. So to get n down, we need a log. The opposite, right, of an exponent is a logarithm, or the inverse operation. So log base of your amount equals your buddy here. You have your pretty print. So you go, what do? You do your math. You go down to option A, which is log base. If you have your old ones, it's more complicated. And then you could see, right, that you type it in. It's very, very lovely. Anyway, so when you do this, n equals 101.1535. Ooh, I can't read my handwriting. I have my calculator, so let's just do it real quick. 35. That is feeling different. So it said something about something. It said smallest population, no carriers, less than 4. So probably safe to round up. So n equals 102. So this would be the trials. When you go to check this, because you should, you would check that this, oh gosh, works. Oops, it does. That's not a wiki face. I know. I don't know if I explained that well, but that's how you do it. So, also 0 factorial equals 1. I'm just going to save that for another day. Okay. Oh, that felt longer than in, well, maybe because it took me so long for the last one, but to be fair, it's Sunday. Okay, so that's that. Thank you. I'm going to give you some of these. Some are a challenge. I know. Ooh. But some of you like that. If you're feeling stuck, this is a new thing for us. I understand that. Try this practice. It has like a nice setup that it does. So this is linked in the slideshow. Please and thank you. Conversely, there are, so like exercises 7K. There are 7 of them. So numbers 1 through 7 would be good practice. I am going to assign some of this for homework though. So just saying. And that is on page 3. Oops. Y'all, I'm going through it. 54 to 55. Capiche? But try this first. Like try this. Try. All right. It's new. For some of us, it's okay to be confused. It is. Smiley face. That's a smiley face. Okay, bye.